Hello, statistical scholars. Let's talk about some quadratics, yo. So, we're going to talk about how you can deal with quadratic shaped terms specifically today. So, what we're going to look at is a materials handler wants to understand the relationship between the strength of plastic cases and the temperature at which the strength measurements were made. So, the engineer suspects the relationship between temperature strength is quadratic and wants to test for the interaction between the supplier and temperature. And he collects 14 samples of plastic cases from manufacturer A and 13 from manufacturer B. So, first, I'm going to show you how they suspected that it came up quadratic. So if we go to scatter plots, and I'm just going to do a simple one, and I'm going to use temperature to predict strength. So strength is going in my y variable, and x variable is going to be temperature. I'm just going to hit OK. I want the simplest one I can, and that looks pretty curvy to me. So I would suspect that this is a quadratic relationship, not a linear relationship. So we're going to try to fix that. Who's excited? Maybe you? Okay, so the first thing we're going to do is we're going to run a simple linear regression on strength versus temperature and include the residuals. If you forgot how to do that, watch. So we're going to go to stat, regression, fit regression plot, line, or you can just do regression fit regression model. Either one. We want to predict strength based on temperature. And I'm going to select graphs and store some of my residuals. I'm just going to do a foreign one. And we'll hit OK twice. And we'll get the following. So, a couple things we want to notice on this. Look at your residual versus fits. Holy moly, does that look quadratic. I mean, it is quite clear that this is not a great representative. Now, the other ways you can recognize this is if you look at your normal probability plot. This clearly has a curvature to it. That's another indicator that you've got a quadratic, especially if the tails tend to curve towards the same direction. Fun times. And then lastly, your histogram looks pretty non-normal. It looks very skewed. It appears we've done a crap job at doing this. There should be something that allows us to fix this. All right, so what we're going to get, I'm just going to shrink this for now. We're going to fix this by, creating some quadratic factors to adjust this. So the first one I'm going to create is just a square of temperature. So we're going to go up to calculator, and I'm going to just call this temp2 to indicate that I've squared it. I think I called it temp squared in the directions, but whatever. Let's just call it temp2. And I'm just going to do temperature, and then you can do the caret key and then square it, or you can do temperature times temperature. There's lots of ways to square things. It used to be in old Minitab, if you did stars twice, it gave you squares, so you could do that too. Fun times. None of you care. Moving on. Bonk. So there's my new column that represents temperature squared. So let's go ahead and run our simple linear regression a second time using temperature squared as our one of our new predictors. So let's go up to stat, regression, fit regression model. And so we're going to add to continuous predictors temperature squared. We're going to hit OK. It's going to give you my residuals versus fits. Again, not looking so normal. Still a little curvature here. Got some betterness in the middle. This looks weird. This isn't great. And here's the reason it isn't great. I'm chuckling to myself because have you ever seen a variation of inflation factor that big? Remember, 5 is the cutoff when this is significant. It appears that this is the worst it could get. It's huge. These are very much collinear with each other. So we're going to fix that by introducing a another factor instead. This is the difference from mean square factor. So there's another name for this that I'm just not remembering, but what do you care? Anyway, so we're going to create something else that'll fix this. So we're going to go to calculator. I'm going to create a new guy. Anyway, what do I want to call this? This is really a standardized temp square. So this is a little more complicated. So here we go. We're going to do parenthesis. I'm going to use temperature minus the mean of temperature. So you can just type in mean of temperature. And then I'm going to close my parentheses and then square this. So I'm basically doing the the difference from the mean squared. So this is basically a variance factor. So I'm including a variance off of temperature with this, and it's squared. So we're going to hit OK here. Woohoo! So this is my standardized temperature that I'm including. And now I'm going to run the regression again with that new term fixed in. So we're going to hit stat, regression, fit regression model. I'm going to remove temp2 and put in that standardized temperature I just made and hit OK. I don't know about you, it's looking a little better. Almost looks the same, except for it's no longer collinear. Okay, so this extra factor in here, the difference mean square guy, is the best fixer for collinearity amongst quadratic terms. So if you're ever not sure what to include, that's what you want. It fixes it every time. So just keep this in mind. It's the best fixer for this. That's all I wanted to show you. That was really short. Awesome. Have a good break.